Hi and welcome to video 2 of our series on definite integration. In this video we're going to look at a couple more examples. Certainly doesn't cover everything, but a couple more examples of simple definite integration, and really your aim should be to build up the procedure and be able to do the simple calculations before you track into some more difficult stuff. So in example 2 we're going to find the exact area, the region bounded by y equals 9 minus x squared and the x-axis. And you'll note here, as we spoke about before, it's mentioned the word area, so we'll be using units squared. Now let's have a look at this diagrammatically just a little bit. So diagrammatically, 9 minus x squared looks like this. It goes up to 9, it's been translated all the way up to 9, which I'm going to say is here. And because it's minus x squared, it flicks down. Now it's asked us to find the exact area of the region bounded by y equals 9 minus x squared and the x-axis. So that is the region bounded by the function and the x-axis, which means we're talking about this region here. Now we know the function we're integrating below. What we don't know is our terminal values. So we're going to go ahead and calculate our terminal values now, and our terminal values will be the values in here. So the x-intercepts of the original function. So let's do that calculation. Y equals 9 minus x squared is our original function. The x-intercepts occur when y equals 0. So remember, y equals 0 provides us with something on this x-axis. So I'm going to let y equal 0, and I get 0 equals 9 minus x squared. This is a fairly simple case. X squared equals 9, and x equals the square root of 9, which is plus or minus 3. Remember, we can have the negative case as well, and you can see this in the graph. There's minus 3, and there's 3. So we're going to calculate the integral between minus 3 and 3 of 9 minus x squared. Now, remember, quadratics are symmetrical, so we could always just calculate the integral between 0 and 3 and double it. I won't do that now, but that would be a clever way of simplifying the problem if you needed to, or maybe if you're missing some other information. So we're integrating between negative 3 and 3 of 9 minus x squared dx. And this is equal to 9x minus x cubed over 3. We don't need to worry about the plus c. And I just write it like this with my upper and lower terminal. And now I'll just substitute those in. So first I substitute in the upper terminal. 9 times 3 minus 3 cubed over 3. And then I subtract what I get when I substitute in the lower terminal. 9 times minus 3 minus negative 3 cubed over 3. And typically we'll aim now to evaluate each bracket separately and then do the subtraction. You can put this straight in your calculator, but it's really important to be careful at this stage. So I've got 27 minus 27 over 3 minus negative 27 minus, and this becomes negative 27 over 3. There's a lot of negatives here. 27 over 3 is 9. 27 minus 9 is 18. That's the first bracket. I'll put it there so you can see that. Negative 27, well, minus negative 27 over 3. Negative 27 over 3 is negative 9. Minus negative 9 is plus 9. So we get minus 18 like that. And the answer is therefore 36. And we write unit squared. Now, this fits into a box that has a width of 6 and a height of 9, and 6 times 9 equals 54. So once we cut out this little bit of area here, we're left with 36. And you know, I'm pretty happy with that answer. It kind of makes sense. It fits about what I expect it to be. So that's the first of our two examples. Let's look at example 3. Example 3 is our challenge example. And it just requires you to adapt your understanding just a little bit. So let's consider how we could do example 3. In example 3, you're asked to find a section of a function with an area below 2 units squared. So whatever the function is, we want the area below to be 2. So we have to make some choices now because we have some terminals. We don't know the function, we don't know the terminals, but we do know the area. So we want the integral between b and a of f of x dx to equal 2. Now my suggestion here would be to consider the fact that we don't know three things, f of x, b and a. And we only have one relationship to set it up. So really what we're going to do is set two of them and determine the third to match. And that's why it says find a section of a function, because there's multiple answers to this problem. So I'm just going to pick a function and just see what happens. So for a bit of fun, let's do something like pick cos x. So I'm going to integrate between b and a, except I'm going to call a 0. So my function will be this one, and start there. But I'm not going to choose cos x, because actually cos x won't have a big, that will be pi on 2, which is 1.47, and this is 1, so it's not actually going to be big enough. So let's make it cos of 3x, or third x, so that stretches it right out here. Okay, so I've got 0, and I've got an upper bound of b, and I'm going to do cos of a third x. But you know, I could have done e to the x, I could have done log, but I would have had my boundary starting at 1 instead of 0, and I could have done any polynomial I wanted to. I'm going to do this with respect to x, and I want to work out the value of b that will allow this to work. And I suspect it's going to be somewhere down here, have a maximum height of 1, drops off a bit, so it's going to be a bit more than 2, but I don't know how much bigger yet. It's probably going to be irrational, so we'll have to go back to the calculator for it. So I'm going to set this up here like this, and I get cos of a third x goes to sine of a third x, but I have to divide that by a third between b and 0. And of course I want this to be equal to 2. And so now I get, dividing by a third is the same as multiplying by 3, I get 3 sine of a third b minus 3 sine of a third times 0 has to equal 2. Now this is interesting because sine of a third times 0 is sine of 0, and sine of 0 is 0. So I get 3 sine of a third b equals 2. And so I get sine of a third b equals 2/3, which is good because that's less than 1. So there is a possible answer. And now I get a third b equals sine inverse of 2/3, and therefore b is equal to 3 sine inverse of 2/3. So that's what I'm going to use for my calculation. I need to put that into the graphics calculator now to work out the value of b that will make this work. Now of course don't forget with sine that once we've done this, before I multiply by 3, there's going to be multiple answers. So there'll be an answer here, and then there'll be another answer here, etc., etc. I only want the first answer. The second answer is going to give me a bit of extra area down here. The third one will give me a bit there, and I only really want the first answer. You'll get a good look at why there's multiple answers to sine later on. But for now, I'm just going to calculate the first answer, which will be the answer that comes out on the calculator. So let's have a look. So here's from the previous video. So I'm doing sine inverse of 2/3, and I'm doing 3 times that. So 3 times shift sine, just check I'm in radians, which I am, of brackets 2 divided by 3, close brackets, enter. So there's my upper bound in radians. Now if that came out in degrees, it wouldn't matter, it just means I'm working in degrees. So I've got 2.189. B is equal to 2.189. And that is, of course, in radians, however you want to set that up, CR or rad. So there's the answer to the second one, and I say the answer quite loosely. You should go now and see if you can come up with a couple more answers. That's a bit of a challenge. If you're working the Cambridge text, there's our suggested questions. Relates to learning goals 15, 16, 17, 18 from our topic plan, and a little bit of detail on the content that you should know how to do. In video 3 of this series, we'll be moving on to exercise 10C and some further investigation on how to do definite integrals. All the best.